Okay, so now let's learn a little bit about sampling. Because in Monte Carlo, sampling is the fundamental operation that you do, right? We will be sampling all the time. Okay, so let's say we have, we have a pseudo random number generator, okay, PRNG, pseudo random number generator, that gives us a uniform random number, in range 0 to 1. Okay. Now, and let's call this uniform random number chi. Okay. So let's say this is the chi symbol. Okay. Now, how can we use this number that we have to randomly sample along a line, let's say, or along a line segment? Okay. So let's say we have a line segment from A to B. Okay. Now, I want to sample randomly along this line segment. Okay, I want to generate points along this line segment using this chi. Okay, it's a uniform random number, so I will be sampling uniformly. Okay, so let's say this is my sample position. So how do I compute my sample position? The S at chi, okay, so given a random number, is equal to, I can say, A plus B minus A chi. Okay. So what does it mean? So let's say I have chi is 0. This term will be 0, so I'm going to be at A. If chi is 1, it's not going to be exactly 1, but let's say it's like almost 1. Then this is going to be A plus B minus A. So this will cancel out and we will have reached B. Okay? So for any other value, you will be getting samples randomly. Here, 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 and so on. Okay? Now, this is easy, right? We can easily sample along a line. Now, let's extend this idea. Let's say we want to sample along a region, okay? A two-dimensional region. But imagine that we have here a corner, I, A, and we have two vectors, V1 and V2, that define our region, okay? It can be like a parallelogram or it can be like a rectangle. Okay? So I want to generate samples randomly, for example, on this region, S. How do I generate these? Now, in this case, I need two random numbers. One random number I'll be using to sample along this vector. Okay? So let's say one sample will bring me in this dimension here, another sample will bring me in this dimension here, and their combination will put me somewhere in this region. Okay, so then I can say S chi 1 1I and chi 2I. I can say this is equal to A plus, okay, V1 times, okay, V1 times chi 1I plus V2 times chi 2I. Okay, so these vectors, again, note that these are not unit vectors, obviously. Okay, they define the extent of the region that we are sampling from. Okay, so here we can simply compute a uniform sample region defined by two vectors like that. Okay.